Today we're going to talk about bisectors and midpoints. Midpoint should be a word that you're kind of familiar with, right? Midpoint. Isn't a midpoint just a middle point? Yep. So the definition of midpoint is a point in the middle. And point in the middle of a segment, right? So if I have a little picture here and I draw a point in the middle, like this, and then we're always going to label that midpoint with tick marks on either side. Tick marks on either side. And most of the time we're going to have a label. So this segment has segment AB, right? And we're going to label the midpoint X and then write our tick marks like that. So the two congruent segments are AX is congruent to BX. Those are my two congruent segments. How many midpoints does a segment have? What do you think? How many ways can we draw the middle? You're right, only one way for a segment to have a midpoint. So every segment just has one midpoint. Here we've got a little algebra going on where we've got those two segments equal. So we're going to use our algebra and say that x plus 6 is equal to 3x, or 6 is equal to 2x, or x is 3. Once we have x is 3, we're going to go ahead and plug that back in to each expression. So here for xm is 3 plus 6, or 9, and then here is 3 times 3, also 9. And that should make sense that those are equal. If I look at number 4, again I have equal segments. 4x minus 9 equals 2x plus 5. I've got x's on both sides, so I'm going to subtract 2x from both sides. Also going to add 9 to both sides, so I get 2x is 14. If I divide both sides by 2, x is 7. I'm then going to plug that 7 back in, right? 4 times 7 is 28 minus 9 is 19. And 2 times 7 is 14 plus 5 is 19. So it makes sense that we would get the same number for both segments. So that's how to find the midpoint. Now we have the midpoint formula, and we just wrote that out for you here. And you've seen this before in algebra last year. What the midpoint formula says is add the x's, divide by 2. Add the y's, divide by 2. Add the x's, divide by 2. Add the y's, and then divide by 2. So if I have the midpoint formula here, and I've got these two ordered pairs, I'm going to look at those x coordinates, 6 plus 3 divided by 2, which is 9 over 2, which doesn't come out even, that's okay. And then the y coordinates, I have 7 plus 2, again 9 over 2. And I would leave my answer like that. That's essentially the ordered pair that goes with the midpoint. If I try that again over here, I've got negative 2 plus 4 divided by 2, which is 2 divided by 2, or 1. And then I have 5 and 3, so 5 plus 3 divided by 2 is 8 divided by 2 is 4. And then that's the ordered pair of that midpoint. So you've seen that before, midpoint formula. Our final thing here is segment bisector, and all a segment bisector does is cuts a segment in half. Cuts a segment in half. You might say, well, the midpoint did that, right? And the midpoint did do that. The midpoint cut a segment in half. But a bisector is essentially a line, making that a little thicker than it needs to be, that goes through the midpoint. So line L there is a segment bisector. How many segment bisectors could I draw, by the way? Couldn't I keep drawing these and keep drawing these and keep drawing these? How many is that? You're right, infinite number of bisectors. Infinite number of bisectors. So if we ask you to draw like maybe 4 of them, first I would draw and label the midpoint, X, with the tick marks. And then here I would draw 4 lines that go through that midpoint. The last thing is just some little segment bisector problems where we're just kind of showing that these are the same on both sides. So 21.7 matches 21.7. And then if I double that, 21.7 plus 21.7, what is that, 43.4, I believe? Yeah, 43.4. 43.4. Here, 2 1/4 is going to match that. 2 1/4, 2 1/4, and 2 1/4 is 4 1/2. 4 1/2. And then here it says AB is 10, so BC is 10, so the whole thing is 20. Segment bisector. So we got segment bisector, midpoint formula, and midpoint.